Hi, this is Mrs. Boykin, coming to you today to talk about composition of functions. First of all, let's take a look at the notation, because it can be written one of two ways. The first way is with an open circle. That is not a multiplication symbol, but it's an open circle. Or our second way, which is to list it with parentheses. No matter which way I write it, it is read f of g of x. Either way, f of g of x. So how would I describe this? I would say that it's when we take an initial value or a variable, and we always start with what is closest to the value or expression or variable. We take the x and insert it into the g function. We're going to take the output of that, the result, and then insert it into the next function, which would be the f function, if it's written in this order. Again, we would start with the g function, inserting whatever is in parentheses, whether it be a variable, a number, an expression, and we would start by putting it into the g function. That output or result gets inserted now into the f function for a final answer. Let me show you what it looks like in a picture. So if, example, I take f of x equals x plus 1 and g of x equals a negative 2x, and I'm asked to find g of f of 3. Well, as I mentioned, we always start with the inner set of parentheses, or we start by whatever is closest to the number or value that we're replacing, and we're going to put it into that function first. So here it says we're going to take 3, and we're going to insert it into the f of x function, which is x plus 1. So in place of that x, I'm going to put the 3, and I'm going to add 1 to it, and the result is 4. That 4 then goes into my next function, which is the g of x function, because when I get done, it's going into g of x, no matter which way it's written. And so when 4 is inserted into the g of x function, which happens to be a negative 2x, we're going to replace the 4 in place of the variable x, and it becomes a negative 2 times 4 for our final answer of negative 8. So g of f of 3 now equals a negative 8. Let's take a look at a couple more examples. In my first example, I have g of n and f of n. Again, I got to pay attention to how it wants me to place the order. So we're first looking at the f of 1. So into my f function, I'm going to replace the variable, in this case here it's an n, with 1. f of 1 equals 2 times 1 minus 4. Order of operations say 2 times 1 is 2 minus 4 equals a negative 2. This result, the negative 2, now needs to go into my g function. So now I'm going to say g of negative 2 equals, and it's important that you substitute with parentheses, because if you don't, you may possibly get a different sign answer than what you intended, times 5 times the negative 2. So again, the output from the f function, my negative 2, is going to become the input to my g function, substituting every place I see an n with the negative 2. So let's go ahead and calculate the answer. A negative 2 squared is 4, plus 5 times a negative 2, so that makes a negative 10, and 4 minus 10 equals a negative 6 for my final answer. Let's do another one. Different notation, different variables being used, but once again it's trying to convey that we start with the g function. And we're going to place the negative 7 in place of the variable in the g function. So instead of t, I'm going to replace it with the negative 7. So we write it as g of negative 7 equals my negative 7 minus 5. And the result would be a negative 12. That result, the negative 12, then gets inserted into the h function, because once I finish the g, I now need to go to the h, into the h function in place of the variable. So h of negative 12 equals 4 times the negative 12 plus 4. Doing order of operations, 4 times the negative 12 is a negative 48 plus 4, which equals a negative 44. Let's go to the next. This time, stepping it up a notch, I'm going to use an expression. The concept's the same. We're going to first start with the g function, because it's closest to what I need to be inserting. So find your g function, and in place of the variable n, I'm going to now list this expression. So g of n plus 3 equals 2 times n plus 3 minus 4. Do order of operations using your distributive property. 2 times n is 2n. 2 times a positive 3 is a positive 6. And then we can subtract 4. Our final answer would be 2n plus 2. We're not done though. We now need to take that output from the g function, and it's going to be the input now to my f function. So here we go with the f function. F of the result, 2n plus 2, equals, inserting it in place of n, your 2n plus 2, and we're going to add 1. I always like to insert it using my parentheses. Now we can combine like terms for a final answer of 2n plus 3. Let's take a look at the next one. Perhaps you can pause it and try doing it yourself, and then compare answers when you're done. Here we go. The first one is taking a look at my h function. And inside my h function, in place of t, I'm supposed to replace it with 2t. So h of 2t equals 2, don't forget you're replacing just the t with 2t plus 4. 2 times 2t is 4t plus 4. And now that we have this answer, the output now becomes the input to your g function. So let's write that. G of 4t plus 4 equals 4 times, again replacing just the t with 4t plus 4 minus 3. Order of operations, do the distributive property, we get 16t plus 16 minus 3. Combine like terms, and we end up with 16t plus 13. How'd you do? That should be your final answer. For additional practice for composition of functions where you can check your answers, go to the following website and you can practice some of those problems and see how you do. Hope you're ready for the test that we're going to have on Thursday, and hope you're ready to work on the composition of functions after your test. Thanks guys. See you next class.